Looks like everything's working. Okay, so the stream's going to start very shortly. Alright, so today we're going to be showing how to set up a Maven environment inside of Windows Subsystem for Linux. There we go, we got our little Linux box from the last video and our dev folder. This time we're going to make a new project inside the Java folder, but this time it's going to be let me make this a little bigger. This time it's going to be set up using Maven. And to do that we actually need to install Maven, because we haven't installed Maven yet. And we're also going to install Git so that we can set our project up with Git. So we'll make a project called Q. Actually, we're not going to make the directory yet. Let's go to our root here and let's install Git. So sudo apt update, just to update it first. We'll do a quick upgrade since we got some packages that look like they can be upgraded. And install Git. Oh, Git's already installed. Perfect. Yeah, cool. So now I'm going to, there's a script I have on my GitHub page that I'm going to get. I'm not sure if it still works, so it's been a while since I've used this script. Where's my gists? Okay, so now we're going to copy this. This is just a link to, I don't know if we have wget installed. Yeah, we do. Perfect. We're going to just wget this file. This is a script from my GitHub called Maven install. If we just run nano on it, this is just a script that will install Maven. It verifies the signatures, unzips. So first we have to make sure that we have GNU PG installed, obviously. And what is the build number for Maven that we want? We usually change this. I'm going to look up the latest version of Maven. Nine 3.9.2. Yep. So we'll do 3.9.2. That should be all we need to change, but I'm just going to make sure that if there's any commands that we don't have, to make sure that we have them. So we may have to have unzip, we have to have GNUPG. Okay, oops. Let's just check if we have GPG. And then we do, perfect. Make it executable. And then execute it. Oh yeah, we have to run as root. Verify and download. Uh-oh. Command not found. We don't have unzip. The one command I didn't check that we had. Let's arm this stuff. And restart because it didn't install. Oh, and I didn't. Oh, there we go. So that installed Maven. And if we, I don't know if it'll be set up yet. No, it won't. Let's just, I don't know if reset will work. No, we gotta exit and restart. Oh, we got Maven installed. That was pretty simple. We can clean up this stuff here. I could probably make this script a little more robust, but for now it works. And if we echo Maven home, and we got Maven home installed right there. Perfect. So now that we have Maven installed, we'll go back into the dev directory, into Java. So we'll make a file, make a directory called Q, because we're going to implement a queue. And since we're in here, go into our Q directory and then do mvn. We want to generate a project with Maven. To do that, we go with Maven, there's a thing called archetypes. To generate a project, you just you do archetype :generate, and I think that's all we need because I think it'll use a default archetype to create it. and it'll probably ask us when we do this. So this is, whoa, okay, maybe not. What happened? Plugin validation issues. Did I misspell that? I did misspell that. It's our key type. Wait for this to do its thing. Okay, so now it's asking us choose a number or apply filter for the archetype. What kind of archetype do we want? There's a lot to choose from here. Okay, what kind of archetype, what kind of project are we working on here? We just want a simple archetype. Let's get the number for a good, a nice simple archetype. So a good one would probably be Maven archetype simple. Let's actually kill this command. Let's run a different command that's going to work a little better here. The default is 2060, but we're going to quit here. No, we'll just, oops, Control C, make sure nothing was created, and we'll do this. So this is the, so this here is going to make a simple project. The archetype ID is Maven archetype simple. So this will make a simple project. And now it's asking for the group ID. So in Maven, the group ID is, the way Maven works is it stores things, it's very modular. So the group ID here defines the current group for this project. So for example, generally, if you have a website, if you're building a website, you would put the com first and then the domain name. So if, say, if you had a website called, if I had a website called poordummy.com, I would do com.poordummy, and then generally, say if I had an application, or no, so this would be the group ID. Well, for this example, we'll use this. And then the artifact ID is the sub artifact. So say if I wanted to make a website with an application called Q and of this group ID, which is poor dummy or dummy, this is how you would go about it. And then the version, it'll default to 1.0-snapshot. The package, you can usually default that to the same thing. And this looks right. And there we have it. Now we have the package. Oops, I made a mistake here. Let's move this Q directory up 1, up 2, and then go back up 2, and then we're going to remove Java Q, and then now we're going to move Q back into Java. There we go. There's our project. And this is what it looks like. So now we have a main directory and a test folder. So we have testing and main. So most of the code will go in the main, and the testing will go here. It didn't generate a resources folder, but we'll do that later. So now the next step is, which I generally think is a good idea. thing called Maven wrapper, which makes it so that you can run your project without having Maven installed, which is very, very good to have. Here we'll do write this command in here. So what this is going to do, this is going to install Maven wrapper, and the version of Maven is going to be 3.9.2. Now if we ls, we can see that we have mvnw installed. This is a wrapper that'll work if you have your code on a system that doesn't have Maven installed, which is very nice to have. So for example, we can run Maven W clean, and that'll clean our project. Clean generally just deletes a target folder. So if you've built your project recently, so for example, if you do mvnw build, this will build the project. It failed because I don't think it can find where Java is. Or no, sorry, it's not build. It would be package. And now we can see that there's a target folder here. This is where our build happens. Everything that, it's like a build directory. But this is the target folder that contains like all the compiled classes and any output jars. So here this is output as a jar. If we look at the POM file for this, we can see this is our group ID. This was all generated, by the way, this POM file. You can do this by hand if you wanted to, but it's a lot easier if you just have the Maven archetype generated for you. We can get rid of this. It's not necessary to have this here. Although for this, you know what, we'll do it. We'll just pretend that this is our website, even though it's not. So here this specifies the, in this properties field, you can define properties that you want. So for example, if you needed something like JavaFX.version, and you wanted it to be version, say, 11, you could make a property called JavaFX.version, and then you can use this in here. Say if in something like a dependency, say you had JavaFX and you wanted to use that, you would do something like this: JavaFX.version, and then it would substitute in the value for this property, which is handy. You know, sometimes it's nice to have all your versions in the same spot, so you can check for changes. You can make one change in the line of code and have it updated everywhere. It's really good practice. So here, actually, we'll do this right here. We'll make one. We'll call this JUnit version. And here we got 3.8.1. And we come down here, and we'll do JUnit.version. So that will substitute it now. We could do the same for these, but for now we're not going to. It's going to take forever to do all that. Wrong button. I'll save that. And now we can open up our editor. We got code installed. We're going to need to install Java plugin setup. So there's an expansion pack for Java. This is, hold on, we got this installed already? Okay, we already have it installed. Perfect. I think we have Maven installed too. Yep. So we don't need to do anything there. That's good. If we open up our Hello World, there we go. We should be able to run it, and it should. Okay, this isn't running it through Maven though. If we go over here, we should be able to see our life cycle. Yeah, we can do Maven clean, and this is going to delete that target folder if we run this. Well, it should have, but I made a mistake somewhere. Okay, let me check this POM file. You know, I might have given you the wrong advice here. I think this goes. Yeah, I think I messed that up. I think the dollar sign goes inside the bracket here. Oh no, this is what I did. Okay, I was wrong. I was right the first time. This dollar sign goes outside the bracket. Yeah. I missed closing this here. Now that should work. Life cycle, we're gonna do, let's do it clean and get rid of that target folder. Now the target folder's gone. Let's see what our test looks like. Okay, this is a default test here. Not really testing anything, but that's okay for now. Okay, let's do, we already did that. What is this warning? Plugin validation issues were detected for one plugin. More or less details use plugin validation property with one of the values. So the next, one of the most common things is to do mvn install. This is going to install it to a local Maven repository, and that's generally in home.m2 directory. So there'll be a directory here, you can ls it, and that'll have our repository. If we tree this directory, it's going to be huge, but it contains all of our build dependencies, including our project. See, this is for faster building, so that way every time you build your project, you don't have to, it doesn't have to download the dependencies again. It stores them and caches them locally, so you don't have to always re-download any project dependencies, which is smart. Saves bandwidth, saves time. It's good to have. Okay, now what do we do? Let's make this queue. Call it queue Java. Why didn't it put the package name here? That's weird. Usually it generates the package name for you. I don't know why it didn't this time. See, the package should be up here, but it didn't generate it. That's okay. It shouldn't be main. What is going on with this? Oh, whatever. Something with the editors acting out, but that's okay. Do an Maven clean. See if it fixed anything here. No, that's fine. It's good. It's complaining. I have no idea why it's complaining, but we will move on. So we make our Q directory file here. So what does a queue need? A queue needs an array. Actually, we're going to make this a generic queue, just like we did earlier with our stack. Extends comparable of type T. Whereas a stack, we didn't necessarily have to make it extend comparable. With a queue, we absolutely need to, because to do certain operations in the queue, it's most of the time it's called a priority queue, and in order to do that, you need to be able to compare your objects. So let's make a private queue, type T, or sorry, an array of type T. Close our queue. And then make a constructor which takes a size and then queue is going to equal a new array of comparables. This is going to be final. Our linter's complaining at us that this is unused, but that's okay. We'll make a quick little function that just returns get raw. Normally you don't do this, but I'm doing it for now. We'll call it get internal. That's going to get us the internal queue, so we'll just return the queue. Normally you don't do that, but that's okay, we're going to do it for this one. Why does it want it renamed? Whatever. I think it's F2 to rename. Call it Q. Yep. That'll work. Okay, so now I've got to remember how a queue works. So queue, I think, needs 2 pointers, a head and a tail. If I can remember correctly, it's been years since I did this, so please bear with me. We'll call it head and private int tail. So we have 2 pointers for the queue, one that points to the head of the queue, one that points to the tail of the queue. It's only going to be a singly linked queue, linked list. know what? Give me a second. I'm going to get my book to make sure that I do this right. I'd rather not have to be putting out some misinformation. Give me a second, please. Alright, I got the Holy Bible here. 900 pages of pure goodness. Look up, remember how to do a Q. It's been a while, so it's nice to look these things up, especially when you're implementing stuff like this. Q isn't even that complex of a data structure, but if I could remember every single data structure out there, I would be an absolute genius, and sorry, I'm not that. I can remember a few of them, but Q 232. Here we go. So the general idea is to have a head and a tail, and our main functions are going to be NQ and DQ. So to add something to the queue, you do this. It'll be public void NQ because it doesn't need to return anything. Although we could maybe return a boolean to say, well, it depends on your use case, but for our purposes here, we don't need to return anything. We're going to NQ a value of type T. And so we just do Q at tail. It's going to equal our value. If tail equals to our Q.length. Tail equals 1. Else if tail, or no, this is just else. Do tail plus increment our tail. There we go. That's how we NQ a value into our queue. And now we DQ. Here we do Tx is going to equal Q at head. If head is equal to Q.length, then head is equal to 1, else increment head, and then finally return X. So there's our quick and dirty queue. Let's just quickly test this to make sure that it works. Why is this still complaining up here? Did I make a typo? Let me just check here to see if we made a mistake somewhere. Artifact ID Q. You know what? I think we need to make a new folder. And then put our Q inside here. And this has got to be .q. There we go. That's better. Because our artifact is, so yeah, our artifact ID is Q, so it would technically be com.prodummy.q. Okay, so now we gotta test this Q implementation. So we'll go down to our test. Let's go back to our POM file and see what version of JUnit we're using. We can probably use a newer version of JUnit. This seems, it might be an older version. Let me see. We can probably use JUnit 5. Okay, we're going to get the dependencies we need here. So the main dependency we need for JUnit 5 is, it's called org JUnit Jupyter. So we're going to get rid of this. We're going to input this. This gets us what we need here. This is plugin management. We're going to add dependency management. And then dependencies. And then a specific dependency. This is going to be a group ID or .junit. Artifact ID JUnit-bomb. And then we need a version. Here we're going to put our variable. And then the type, which is a POM type. I think POM stands for Project Object Module. I might be mistaken, it's been a while. And my memory isn't 100% all the time. Just being honest, that's all. Okay, so now that should do it. No, we have to update this version. So we want to use 5.9.3. Okay. And in here, this is going to be changed because Java JUnit, the JUnit 5 is a lot different than the older version of JUnit, so we're just going to get rid of all this and this And then the way to specify tests, you use the annotation called test. And then you just specify the type of test. So this is going to be our Q test. Actually, yeah, Q test. We're going to create a new Q, make the type integer. Get size 10. Q.nq. Oh. Not using the right Q here, so we have to import it. Com.q. There we go. We're going to enqueue a number. Let's just enqueue 10. Then 11, 12, 13, 40, whatever. Oh yeah, well let's add a print function to our queue. So our queue is encapsulated by between head and tail, I believe. So our print function should be pretty simple. So public void print. Oops. And we'll just do arrays on stream queue. Is that gonna work? Yeah, so queue and then head and tail for each system out println. I think that should do it. We'll see. And then we'll do q.print. Let's just run this test quick and see what happens. Here we do Maven clean test. Oh, we got a bug. We made a mistake somewhere. All method references, because we're using Java source 7, we need to go 8 or higher. And that's an easy fix. So we just go to our POM file here, and we change these two values to, we're going to use Java 11. That's a little newer, and it's fairly stable in my opinion. 1.7 is fairly old for Java, so we're going to use Java 11. That should fix this. Oh, wait a minute. Oh yeah, and we made a bug here. We got to typecast this to a T array. Cannot find symbol. Oh yeah, we have to import arrays. Java util stream.arrays. Yep, perfect. And yeah, let's run this again. Let's see if we got a. Where's our next error? Okay, so it's not stream.arrays. See, it's not. There's something wrong here. Let's give this For some reason, Java's not working correctly. Our environment's not working correctly. Java's fine. It's our environment here is acting up. What did I miss? Let's close the folder and reopen it. There we go. There we go. Just auto import that. See, that makes it easier. It's if you don't know exactly where every package is, just sometimes it's easier to lean on the crutch of the IDE. Okay, so now we can run that again. Oh yeah, we need to import this as well. This is our test annotation. Ah, look at that. Now we can run it straight from the IDE as well. Very nice. But we'll do it from the command line since we've been doing it that way. Okay, so our test ran and we printed out our queue. Alright, so now let's take our queue and dequeue a value. So this value should be 40. And we'll do a simple assertion statement here. Assert equals, and then I think 40. I think it goes expected and then actual. So we have to make a static import for this. Yeah, so it's expected and then actual. So we expect 40. This is what the actual value is. We can also just take this, stick it in here, save the use of the variable. So if we dequeue, for now we're just going to take 3 off. It should be 13, and then 12. I believe. No. Should be 10, 11, 12. Right? I don't know. This is why we're testing. So let's print our queue again after we've removed the 3. And let's test it. This time we'll use the editor because why not? And it passed, so that means our queue values are right. So let's also assert that after we've printed it, that the last 2 values are correct as well. So this should be 13 and this should be 40. And then here we're just going to do a print statement to do another print line. Put a couple in there just to distinguish. Okay, let's run this test again. So we got 10, 11, 12, 13, 40. And we got 13, 40. And then nothing. Perfect. So our queue works. Simple queue. It's not nothing complex here. Get rid of this. Yeah, and that's how you set up a Maven project. Here's another nice tip. If you ever need, this is the beauty of having Maven in your project. So say you needed an external dependency, you just import it. So there's websites, I think it's called Maven Central or Sonotype. There we go. Let this load right here. See here, and you can say you wanted a, I don't know, what do they got, a SHA hashing library or something. Type in SHA 256. Okay, never mind, call me a liar, it's not there. Is there any PNG libraries? No, what the hell? Browse. Okay, this isn't the right website. Give me a second. I'll get you the right website here. This is the one that I normally use too. It's fairly good. It's not the best, but see what kind of stuff we can find for PNG. Now, I'm not saying that what I'm looking up here is the optimal library, but say we needed K-hash for whatever region. Say we wanted to use this hashing function, right? Bang. Go here. First you check. This is nice to see here because it tells you if there's vulnerabilities in your dependencies. So I wouldn't use this personally because I see these here. Even if it's fine, I don't like the idea of having vulnerabilities in dependencies. And you shouldn't either. But if you needed to, you could copy this, add it to your Maven project, and then happily use the library. That's the power of Maven. Yep, and that's, let's go back out to our terminal here. Let's do a Maven clean. Let's see what our directory structure looks like now. It hasn't changed too much. So we have our Q class and our app test. Ideally, you would normally when your project structure here. So with this test, you would also have a folder called Q because you want to kind of mimic the folder structure of your main here, and then you would have your test called Q test of Java. That's normally how it goes. Let me fix this. See, because I was rather hasty here when I did this, so. And then name this Q test. And then you see we don't need this import because we're in the same folder. That's the point of doing that. Yeah, and that's it. And we can get rid of this because this isn't really doing anything. So that's generally how it should look. Let me do another tree. So now you can see we have our, hold on, let's get rid of this target folder. So now you got Java com pour dummy Q. There's our Q implementation. And then we have our test, which is also in Q. And it's just called the name of the class, the test at the end. That's normally how it should be done. Let's run this again just to make sure it works. Why didn't it pass? You know what, let's reload the editor again. Sometimes this editor isn't 100%. It can be buggy. So we gotta sometimes just reload it. And I think it may be because it's on a remote host and it's syncing file system changes and it doesn't sync instantly, so that's my theory, but I could be wrong again. Oh, what's going on here? Class not found exception. Why is that? Oh, because we did a Maven clean. We likely have to rebuild. See if we have no target folder, I don't think. Well, we do, but it's not built. So we gotta do Maven clean install. That will clean the target folder, rebuild it, and it runs the the nice thing is it runs the tests. If you wanted to build it without running tests, you do Maven and then -d skip tests. That'll build it without running the tests. Most of the time you want to have your tests built as you when you install it, because it'll alert you of any problems. I wonder if there's any code coverage plugins that we can get. Although I think we can test with coverage right in the IDE here. Let's go back to our testing. All results. Excuse me. Don't know if this IDE will allow us to do code coverage without a plugin. We have this, which is nice to see. We may need to find a plugin here for doing code coverage, because it's nice. The point of using a code coverage tool is when you're running a test, you want to make sure that your tests cover 100% of your lines of code. That way it's a lot less likely to have a bug. See here, he's got 100% code coverage on that class and no coverage on those classes. It just tells you how well your test suite is. Let's get a which one were we looking at? Apex Code Coverage Visualizer. That looks pretty good, but this one also looks fairly decent. This one has the most installs. But what we want is one that works with Java. So we'll do JUnit code coverage. Okay, it says it's fully automatic. Let's see. Wait, does it not? This has got to have code coverage in here. Maybe it doesn't have code coverage. I think it's Control P. Control P. Control P to open up this menu. Yeah, we have no coverage. Let's just get this. We'll try this out. Take a risk. It says it does it automatically. Let's see. And since we did that, let's reload our editor. Okay, let's run our test. I don't see any code coverage here. Let's see. Control P. Oh yeah, it's gonna be colon. This one. So we'll say generate test suites 4 file. See how this works. It says it's generating tests. This is making me nervous, dude. Let's go get this sim flower out of here. Clearly it's not working, so we'll get a different one. This one has the most installs, so we'll try it. Run this, let's see if it's automatic. It's not. I have to do Control P. Display coverage. Control Shift 7 will display the coverage. Control Shift 7. Oh, we have no coverage XML. Dang. Let's see if we can find the command for to get JUnit to export a coverage file. Export coverage XML. Maybe it's not possible in this IDE. There might not be a tool for it. Oh, okay, we need to add a plugin. Java code coverage plugin. Alright, so we'll do this. Going back to our POM file. Under build plugins. We're at the bottom here, we're going to add a plugin. It's called Jacoco. Let's get the latest version is 8.10, so we'll go up to 8.10 here. And we'll do this as well. Jacoco version. And we'll make another thing up here. Jacoco version. Stick the version here. That way if we ever need to upgrade later, we just upgrade this one spot. Alright, now we gotta run our command to run the test with coverage generation. So here it is. You just do Maven Jacoco prepare agent test install Jacoco report. There we go. So now we should have the test results here. Oh, I did not mean to do that. I was doing a dependency analysis. Whoops. Wrong button. I'll let that run in the background. Let's cancel that. Where is our coverage? So can't locate the coverage file. Let's rerun our command here. There we go, we got 81% coverage. See this? Now we have line coverage here, so we can see our tests cover these lines, but it doesn't cover this one because we didn't fully fill the queue, so this line of code never got evaluated. So if we go back to our test and see we have 5 values, if we change this to 5, we should have a better coverage because, okay, so I'm wrong, because if we change that to 5, it's not going to cover both routes. This is an if statement, so it's only going to, what's going to happen is we'll change it, but then this will get evaluated. Well, yeah, maybe it will. Let's see. Let's rerun our test with coverage. Can you stop this? No, it's just going to keep going. That's dumb. No coverage. Why is it not giving us coverage again? This is being buggy. Let's restart it. Close the folder. Before we do this, we're going to clean. Then because that way it deletes the target folder and then redoes it all. Why is it not picking up our coverage? There we go. 81% coverage. This should be getting called. One, two, three, four, 5, or size 5. It's gonna fail likely here. Yep. Why is it not working? That line should be covered, but it's not reporting correctly. .81% coverage. That's not terrible, but it should be 100%. Let's debug it. Let's debug it and see why we're not getting what we're supposed to be getting. So over here, debug Java. No, we don't want to do it this way. Let's go over to our testing. And we'll test it with debugging. And it didn't work. Okay. Probably because we need to put our breakpoint here. We'll do that again. There we go. Let's jump into this. Step into. Yeah, okay, debugging in this IDE is not ideal. Oh, there we go. We had to jump in a couple times to get where we wanted. So now our tail is 4. Our value is 40. The length is 5. What does our queue look like? Our array look like? We have an int. Oh yeah, okay. This has to be -1 in both the cases. Now if we step over this, let's just stop and rerun our test. Go, step in, jump over this, sets our tail, and then return. Oh, we got a bug in our print method now because we updated our tail was updated here. Yeah, we don't want to actually do this. But why is this never getting evaluated? This line of code should be getting hit, and it's not, and that's weird. Anyway, I don't really trust this IDE very well. It's not, in my opinion, it's great, but it's not the best. I've used better IDEs. It's one of those things where it's you know, it's the jack of all trades, master of none. You know, it's good at using. It's good for many different languages, but it's not a master at every different language. There's still lots of bugs, especially with Java. But for the most part, it's okay to use. I could also have a bug in here that I'm not aware of or not seeing at the moment. Anyway, that's how you set up a Maven project with coverage. Let's clear this. Let's Maven W clean. There you go. Thank you for watching.